All right, 2.2, organizing quantitative data, and also called the popular displays. So we have quite a few objectives here, so let's get moving on through those, okay? So the first step, determining quantitative data, is to decide whether we have discrete or continuous, because we have to handle those two things differently, and we may have to deal with some classes and different things like that. So we first need to do that. So let's look at discrete first. Here in objective 1, and so we want to organize those. So discrete, remember, is just single items, and so we just have those pieces. So here we're looking at Wendy's, and it's the typical number of customers who arrive during the lunch hour. And so they go through these intervals and they see how many, okay? Well, then they break it down into the number of customers, they do their tally marks, they look for the frequency, and then they get their relative frequency. And so we're able to put together all of those things real quickly just by simply counting those things with that and looking at the number of customers. All right, now we can create what's called a histogram. Now, a histogram is a type of bar graph, but we're going to be looking at putting those things together side by side, so it's all going to go as one big object there with those. But the width of each rectangle is going to always be the same for sure, and they're going to touch. That's kind of really your big difference on those. Okay, so let's construct a histogram for that. So if we look at the frequency here, notice it looks like a bar graph, but again, there are no gaps in between those, and all of our boxes are the same here. All right, and then we also have our relative frequency. So this is what our histograms will look like for this. Okay. All right, now the rectangles in histograms touch, but the rectangles in bar graphs do not. So that's, I kind of mentioned that a couple of times there. That's just the big difference between a simple bar graph and a histogram, is that the bars actually touch in a histogram. All right, continuous data. So let's look at how we need to organize that. Now, classes, these are categories in which data are grouped, and so that's they have a large number of different discrete data values or continuous data values, okay? And so we need intervals. And so here's a example of that. So suppose we're looking at ages, and we don't want to do every single year, so age 15, age 16, age 17. We want to look at groups. And so here we have 15 to 19, 20 to 24, 25 to 29, and so forth with those, okay? And so we have created these groups. Now, the only bad thing is we don't know specifically what ages these 443 people are, but they are somewhere between 15 and 19. All right, now we have what's called limits of the class. We have the lower class limit and the upper class limit. So the lower class limit is the first number, and then the upper class limit is the second number. So in this first one, our lower class limit is 15, our upper class limit is 19. The next one is 20 and 24, and so forth, okay? Now, the class width, we got to be a little careful. We think that we're going to subtract these numbers, but not really. We actually are taking the 15 and the 20 here, and we're subtracting those numbers. So 20 minus 15 is 5, and that's where they get this. So even if we go down here, 40 minus 35, that is still 5. All of these should have the same width when we're looking at those pieces, okay? And so we want to make sure that we're doing that correctly. All right, so the one exception to the requirement of an equal class width occurs in open-ended tables. So open-ended is the first class has no lower limit, and the last class has no upper limit. But we won't look at very many of those. But here's an example of that. So we're looking at these ages, and we say just 65 and over with that. So that would be open-ended. All right, so here we have data of 50 parking and camera violations in New York City. So we want to create a frequency distribution for the data. Okay. Now we want to have equal classes, and so we want to look in how we want to divide those up on those. Okay, and so we range from 65 to 322. So if we go back to our table here and find our smallest one is 65, our largest one is 322. So we decide that we want the first class to start at 50, and we're going to go by 25s because that's a pretty good distance. Now, some of that stuff will be up to you. You just want to make sure that you're creating good sized classes. You're not trying to do too big of a piece, but not too small. There can be a difference between too little information and too much information. So it is a fine line to walk, but you'll figure those things out as you go. All right, so then we go through and we would tally up all of these things, okay? All right, so here is that graph. Now notice here, because of our class width is 25, here we go 50 and then 75. Well, we're in money, so we needed to do 74.99, not just 74, because we could have those coins in there as well, and so we want to make sure that we're getting those pieces. So be careful with those types of things. Sometimes, if we're talking about people, we don't need to worry about those decimals, but if we're talking about money, we do. So we need to be careful with those types of things. All right, so here are just kind of some things. The lower class limit and the class width, they're arbitrary. That's sometimes up to you. A lot of times the computer is going to tell you what they want, but if you were doing this on your own for a report or something, those things would be kind of what is the best visual, what are you trying to get across the most there, okay? There's not one correct frequency distribution for a particular set of data. We can have multiple that give us different views, okay? And now some of them do a better job of illustrating the patterns, so we do want to be careful, okay? All right, and so then finally, like I've said before, use whatever is best summarizes the data, okay? So a few guidelines here. For choosing the lower class limit, choose the smallest observation in the data set and then a convenient number slightly lower than that. We typically like 0s and 5s, but we don't have to. We just want to make sure that we're a little bit lower than those things, okay? The class width, here we look at the number of classes, and we like to be somewhere between 5 and 20 classes. If the data set is smaller, probably the fewer classes we should have, okay? The larger it is, the more classes. Now, to find the actual class width, we would take our largest data value, smallest data value, and divide by the number of classes that we want, and that would give us our class width on those. And we always want to round this up to a convenient number, okay? We don't want to do decimals on those. All right, so for instance here, they had 322.61 minus 65, and then we divided by 11, so that gave us 23, and we decided to round that up to 25 as the class width on those. Okay. All right, now we need to actually construct the histograms from those. All right. So we would look at our previous example here. And so again for these pieces, okay? Now, one of the things, let me go back to this one. So notice here that on our histograms, we are looking at our distance, so we're going from 50 to 75. There's our first box, and so each one of these would give us where our boxes need to be, our rectangles need to be. So from 100 to 125, we would go up to that piece there for that. And the same thing over here on this one. Okay. All right, and so this is just using, again, a computer program to do the same thing. Okay. Now we can also represent these things through dot plots. So dot plot is drawn by placing each observation horizontally in increasing order and then placing a dot above each observation. So it's almost like we're doing the tallies, but we're using dots instead, okay? And so this is what it looked like for that Wendy's example that we had earlier. And so you're just putting those dots up there, and to know how many that there are, we would count the dots on those and be able to see them. Okay. All right, now finally we need to identify the shape of a distribution. So we want to be able to look at our histogram or our dot plot and be able to go, what shape does it give us and what does that tell us? All right. So if it is straight across, we call that uniform distribution or symmetric. So everything has the same distribution, so it's going to go straight across here on those. Okay. The next one is a bell shape, and so if we were to actually draw our line here, it gives us kind of this bell shape, or pretty close to it. It may not be exact, but it's going to do that. And so we have the bell-shaped distribution. We're really going to focus on that one throughout this semester. We're going to go back to that as the one that works the best for us. Okay, and then we can have some skewed, and so this one is skewed right. Notice that there is a tail on the right with it, and the peak is on the left for those. So if it has a tail on the right, we call that skewed right. And if there's a tail on the left, then it is skewed left. So again, over here, skewed right gives me a tail over here, and skewed left gives me a tail on the left-hand side. All right, now we do not describe qualitative data as skewed left or right or uniform. This is only quantitative data that we do that with. And it's also important to recognize that data will not always exhibit behavior that perfectly matches any of these. They will be close to those, and so we want to keep that in mind as we move forward. All right. All right, so here we have this one. How do we describe this one? This is fairly symmetric. However, it is not bell-shaped. Okay, so it's just kind of got a weird one with those pieces. Kind of goes up, comes down, but jumps back up. There's a little bit on each side of that, but this one doesn't really fall any of those types of pieces where it's a good bell shape. Kind of goes up, and I would say maybe for the most part would follow that bell shape a little bit, but not perfectly. Okay. All right, so those are the things that we're going to need there for 2.2.